All right, 4.1 day 2, this is antiderivatives and indefinite integration. Our objective will be, we want to find a particular solution of a differential equation. And then the second thing we're going to look at is solving problems involving acceleration using integrals. So the first part, finding the particular solution. Some problems you'll see they will give an initial condition to determine what C has to be after you find the antiderivative. So yesterday we always put the plus C because there's an infinite number of functions that had that specific derivative. So now you'll be given an initial condition to make sure that we actually figure out what that constant is. Okay, so for example 1, it says find the general solution to f prime of x equals 1/3 x squared, and then find the particular solution that satisfies the initial condition f of 1 equals 3. So we will start by finding the general solution. So let me move this up. If f prime of x equals 1/3 x squared, okay, we want to think about f prime of x as dy dx because this will help us kind of get set up to solve the differential equation. So we have 1/3 x squared, and what we end up doing is we move that dx, this dx, if you kind of think about this as a fraction, right, by multiplying both sides by dx. And now we are set up to integrate, okay? So what we can do is we will integrate the integral, or introduce the integral symbol. If we do that on the left, we have to do that on the right. So the integral of dy is just going to be 1y equals, and then we will do the integral of 1/3 x squared with respect to x. And then that will give us y equals 1/9 x cubed plus c. So now we want to look at the particular solution that satisfies this initial condition of f of 1 equals 3. So what that's telling us is that if we have f of 1 equals 3, we know that this right here needs to pass through that point, and that's how we can find the c value, okay? So we know that it's passing through 1, 3. So what we can do is plug in 3 for y. So we get 3 equals 1/9 plus c. And if we subtract 1/9 from both sides, we get 26/9. And so the particular solution will be y equals 1/9 x cubed plus 26/9. Okay, and this up here that we found was the general solution. Okay, so we know that when we do when we find the antiderivative, there's an infinite amount of antiderivatives, and so to find that particular one, you have to have a given. So we were given 1, 3, so therefore we could find out what c is. All right, number 2, a balloon rising vertically with a velocity of 16 feet per second releases a sandbag at the instant it is 64 feet above the ground. Two parts to this. A, how many seconds after the bag is released will it hit the ground? And B, at what velocity will it hit the ground? okay? So in order to answer the first question, we need to find our position function of the sandbag, okay? So if you look at what's happening here is we have a bag being dropped, and what is going to bring the sandbag back to the ground is gravity. So since we have, since we're using feet, the acceleration of the sandbag will be negative 32 feet per second squared. Okay, so what we're going to do is we are going to integrate so we can get to our position function, right? Because if we have our position function, the derivative of the position function is velocity, and the derivative of our velocity function is acceleration. So we know the acceleration function, so we are going to set that up. So if we have a of t equals negative 32, and we integrate this, so we're going to take the integral of a of t dt equals the integral of negative 32 dt, because this is with respect to time. The antiderivative of the acceleration function is our velocity function, and we add 1, and then we have plus c. So now this is where we have to look at our initial condition to help us find c. So since we release the sandbag at time 0, so let's write that down. The initial condition is zero comma 16. Because if you look there, it says it is rising vertically with a velocity of 16 feet per second. So when we release it, that is your velocity at time equals 0. So we have this velocity function, so that means that v of t equals 16, time equals 0, and we need to find c, and c equals 16. So therefore your velocity function is negative 32t plus 16. So again, to answer these questions, we need the position function. So we have to integrate one more time to get there. So what we're going to do is we will take the integral of both sides, with respect to time. So the antiderivative of the velocity function is the position function, and we'll get negative 32t squared over 2 plus 16t to the first over 1 plus c, which is negative 16t squared plus 16t plus c. And again, if we use our initial condition to find c, the bag was dropped when it was 64 feet so the initial point or initial condition is 0 comma 64. So that means when I plug in 0 for t, our output is 64. So our position function is the following. And now we can answer the questions. So obviously we have a lot of work to get to that position function. And now to part A, what it said was how many seconds after the bag is released will it hit the ground. So what we'll do is set this equal to 0. And if we factor out a negative 16, we're left with t squared minus t minus 4. And that is not going to factor, so we are going to have to reach for our calculator or do quadratic formula. But you can set this in graphically, and that'll give us, if we solve it, negative 1.56 and 2.562 seconds. Obviously, negative doesn't count. So our answer for part A is approximately 2.562 seconds. And then part B said at what velocity will it hit the ground? So we're just going to use that time and plug it into our velocity function. And if we throw that into our calculator, we will get negative 65.984 feet per second. Okay, so that problem showed us how to use that initial condition over and over to find our particular solution, so we could actually find our velocity function for this problem as well as the position in order to answer the questions for A and B.